5, 5?
Yeah, I've got all kinds of these. 24A.
All right, hold on. 24A?
Yeah.
Okay. All right, so help me out. What are the operations happening up here? What are the operations?
Multiplication.
Multiplication and exponents. Right. You guys good? So there's only really multiplication happening here, because the powers, I can't really do much with them. So when I'm multiplying, what do I look for when I'm talking about things with powers on them? I'm looking for like bases. I love it. So where are my like bases? Yeah, so how many A's do I end up with? Yeah. How many A's do I end up with?
-3.
Yeah. And then how many B's do I end up with?
3.
-3. All right, so far so good, right? There is one last step that you must do. It's just convention. It's sort of like telling me the answer is 3/6. Well, you make it freaking 1/2, right? Don't stop with negative powers. Wherever the negative powers are, just flip them. So this becomes
1/8.
1/8 to the third.
11.
Yeah.
Cool.
And that's the answer.
Yeah, that's it. Cool.
So, so you don't put the 1 in the line until after you do the process of the flip.
Exactly. Because if I move this down and move this down, there's not a 0 left up top. There's that understood 1 that's always there. He suddenly has to show up because there's nobody there to stand in front of. So when I write A, do I write 1A?
But what I was doing was I was putting 1 over A to the negative third, B to the negative third, and then I was flipping it, and then I'd have A to the third, B to the over 1.
But these, how did these get down there before? How did these get down? You put these down, but why would? Let me see how to say this. All right, so you're cool with this,
Now,
right?
yeah, it makes sense now.
But I'm not sure how you got to this.
Right, Nick? Yeah, me either.
Okay, all right. Because when I have a single line of stuff, I'm just going to combine my like bases, right? Just add the powers of the like bases. That's what I'm going to do. And then I'm going to step back and see, has anybody got a negative power? Yeah.
30, A and B.
All right. So I think part of what's the thing about 30A is it just looks loaded down with stuff. But 30A is the same problem as this, except there's one thing I have to do first. Yeah, my operations are still multiplication and powers, but can the powers do something now?
Yeah.
And of course, order operation says you do powers before you do anything, right? Well, parentheses and then powers. There's no parentheses here, really. So what happens here?
-6.
X is -6.
Times.
So I'm just multiplying those together, right?
No, X4, Y4. Times Y. Minus 5.
So, you wouldn't go 1 over X to the 6?
You could, because that's what that is. You totally could. Are there fractions in the problem to begin with? No. So I won't really bring them in until I have to. That's one way to do this. There are multiple ways to do this problem. Why is it okay that I still have negative powers? Because I'm not done yet, right? And the next thing I'm going to do is I'm going to combine my like bases here, right? You guys kind of with me? And after I do that, it might not be a negative power anymore. I want this to make sense. Like if this would have been x to the 8th, when I put these together, it would have been squared. It wouldn't have been negative. There's no reason to flip anything then, right? Is it wrong to flip it right there? No, it's not. So let's see what it would look like if I did that. So here's one way to do it. Another way to do it is to flip this. So it's 1 over x to the 6th, I like it, times x to the 4th, y to the 4th. And then, well, wouldn't you do this here? Nathan? Flip your negative powers?
No, I just put right at the -1.
Sure, okay, all right.
And then I put it.
Yeah. You're doing a few different methods at once, but you're applying that. That's beautiful. What you got so far works. Part of the problem with exponent problems is there's a lot of different ways to do it. Say again?
Show me the way you would do it.
Here, all right. And to give you, as you're learning something, it really kind of sucks when there's more than one way to do it. And I always have to fight against showing you too many ways, but I want to show you all the ways so that you can pick the one that makes the most sense. But then I get people that do 2 ways at once, and that sucks because that's no good. It's not going to work. The reason I do this the way I do it is because there are no fractions to begin with. So I'm not going to introduce them until I have to. Does that make sense? So if I had a problem like this, we've done a problem like this before. Who remembers what I do first here?
You still bring all the on the bottom.
I flip all the negative powers because there is a fraction already. So I might as well flip the powers because there's already a top and a bottom kind of like established. I might as well flip the powers, get rid of the negatives. Here, I want to first see if anything's left negative after I put these together. How many x's do I have here now? X to the what?
X minus 2.
Negative 2. Y to the?
Minus 1.
Now I go, oh, okay, they both got to flip. But it's not wrong to flip it. It's not wrong. It's just got to make sense to you. One of these ways. You've got to try to let it make sense to you. That's really the next step. And that's what's difficult as a student. You're like, I'm just learning it. How am I supposed to pick a method that makes sense when I'm not even sure about the idea itself? All right, so I'm trying to give you some triggers. There are no fractions. I'm not going to make them until I have to. That makes this a little easier, in my opinion. Right? Yes, sir.
I had a question on the section.
Where are we at?
5.5.
Number 1.
So are you just basically making it 1 over a to the negative?
It's so how many a's do I have up there? Like n of them, right?
Yeah.
And it's currently negative power. So the negative power says take those NAs and flip them. Now real quick, don't write this down. If I did this, they would want to flip up again. And then if you write it with a negative power, they want to flip down again. And it would just go forever like that. And you're like, okay, that problem is okay. Let's put that over here. Little papers jumping all over the place. So it's sort of like saying, if I said, what's 9 divided by 3? And somebody said, oh, it's 3 over 3. What would you tell them that's wrong? Why is that wrong? Do you see what they did? Why is it wrong? What, that over 3, should it still be there? No, because it did its job. 3 goes into 9 3 times. It's not there anymore. So when you flip it, is it still negative? No, because it did its job. It's not negative anymore. It flipped it down. It's done doing what it wanted to do. So whenever you move something with a power, the power is going to change signs. So this might seem strange, but if I have 1 over a cubed, I can rewrite that as a to the
-3.
Yeah. I like it. If I wanted to force it up for some reason, and there are sometimes you want to do that, to be honest, you just change whatever the power is, you change its sign when you move it. Yes.
Technically, that's what you do with cross cancel. Throw a negative up there, or throw a negative.
Oh, that's kind of a way you could do that. Yeah.
That's what I've been doing when I wanted to cross cancel or some other thing, and I didn't know what I was doing.
Oh, so like, all right.
Cross canceling exponents, so to speak.
So if you add like, let me make,
Reducing again.
something like that. I mean,
No, I just mean like 2x2, y2 over 4y4 x5 or something, and then you could, instead of 1 wondering how many Y's there are, you flip them into the other one, you know. You take
Yeah, you could. Now here's what's neat. You could take those, and that would become -2 down there, right?
Yeah.
And then 4 minus 2 is 2. I like it. So just looking at that one piece. I would say, the way I show it is, 2 would be left alive on the bottom here, right? But to really, really see that, I like that, Nate. So you can bring it, you can force it down. So now changing it, 4 minus 2 is 2. So there's 2 on the bottom. Kick ass. So that's what I mean. There's a way to look at it that I didn't even really show you. So it's awesome you came up with it. That's what math is. It's saying, okay, teacher, that's an interesting concept. Let me make it my own. That's what math is. You got to make it your own. You got to say, I understand this. Let me do it a way that makes sense to me. But always check it with me to make sure that way works in general. You might just be getting lucky, but that's beautiful. I love it. Yeah.
Could you do number 30 on 5.6?
5.6. All right, I think this will be the last homework question. We got to get into some new stuff or some old stuff. I like this problem because, well, you'll see in a minute why. I don't know if you've done this one yet. So how do I set this up?
2x minus 1 divided by 4x squared minus 4x plus 1.
Cool. I like it. And then we had a nice discussion yesterday about, and I think I got everybody to agree about what your brain does when you do math. That's part of what I know for real, for sure. So that's why we're okay with just looking at this first piece. 2x times what is 4x squared?
2x.
2x. So 2x times 2x, amazingly enough, we just said it was freaking 4x squared. And 2x times -1.
Minus 2x. 2x.
And then, of course, you
Change the sign.
Because what do we always do here? We subtract whatever's there, and subtracting an expression is changing the signs. Yes? Yeah. Whatever you put up here has got to multiply by this and go there. So real quick, remember we had this thing, whatever it was?
Yeah.
Whatever.
It's confusing to see the extra number because I'm still learning
I'm with
this
you.
method.
Real quick, go with me for a second. 2 into 7 is 3, so 3 is a good first guess. But then what would I do immediately? Would I just go 3 times 2 is 6? No, I'd say 3 times this whole number, of course, right? Then I take this into account. So I'm doing the exact same thing. This gets me started, and then whatever's there's got to multiply this whole thing. This guy's got to come into play at some point. That guy is just like the 3, 4, 5, the extra digits. It's more that's actually the exact thing that it is. It's kind of neat. All right. One of these is going to work. So these are gone.
Yeah.
-2x
Plus 1.
plus 1. So what do you multiply 2x by to make it -2x?
-1.
Beautiful. -1 times 2x is -2x. -1 times -1 is
1.
1. And then you
Change the
change signs. So what happens here?
0.
0. What does that mean? Can somebody tell me what that means? Don't say there's 0 remainder. That, of course, I've already written that. What does a 0 remainder mean?
It goes in.
It goes in evenly. Now be even more precise.
Nothing left over.
You're right. Nothing left over. Okay. 3 goes under 27. 9 times with nothing left over, right? That means that 9 times 3
27.
is 27. So this means that 2x minus 1 times 2x minus 1
Gives you 4.
is 4x squared minus 4x plus 1. If you FOIL it out, it'll become that. Do you guys see that? And maybe some of you guys are like, well, of course, and some of you guys should be like, oh shit, I didn't think about that. But that is what it means when it goes in evenly. This is actually kind of a way to factor then. What we do in the higher level math is we take this process and we make it better because this sucks. I agree with you, but oh well. That's what we got. Long division. That's what we got. So in later math, we do some neat stuff to make this a little bit quicker. And then it's a way to factor really disgusting things. Sorry, so that's just to give you an insight into why we do this. And then I build a process on this, which is better than this. And then we use it to factor stuff. And you're like, oh, that's good for you people. But right, but that's kind of like what this is leading to. I like it. All right. So let's get back into. We left off in 6.2, so I want to bring us back up to speed with 6.2. Is that still done? Yeah, cool. All right. So we're past GCF and grouping. Nobody's asked me any questions on it because they haven't done the homework yet. So get going on that. So you have questions. What we did, where we left off, is stuff like this here. What you got, Jeff? Okay. So one reason why I assign as much homework as I do is to get us ready for stuff like this. After doing a lot of multiplication of stuff, of binomials and foiling stuff out, we know that this would come from this. So if I did x plus 5 times x minus 7, I would get something. I wouldn't get this, but I get something that looks just like that. And that's why you do multiples of those to get ready for why it makes sense. The answer to this, to factor this, has to look like that, because I know that's where it came from. So how do I make x squared? What would have been here and here to make x squared? X and x, I like it. So that's why when there's a 1 right there, these problems are so much easier, because then they just become like a number puzzle. What's the number puzzle? What do I have to figure out? I have to figure out what goes here and here, and what has to happen with those numbers. What two things?
Have to add to 10.
I got to add to 10.
Multiply to 24.
Multiply. There it is, Jeff.
Is that an exclamation?
Upside, yeah, sure. Multiply. So 24 is not a difficult number to work with, right? The more difficult this number is that you have to multiply to be, the more factors it's going to have, the more I would actually start with this number. I showed you that last time. So like, for example, right here, this is not a very hard number. Some of you guys should know the answer already, but I could say, okay, what adds to be 10? 2 and 8. But 2 times 8 is not 24. 3 and 7, no. 4 and 6, there you go. Right? So it doesn't matter which one of these you make work first, you just check to see if the other thing happens also. So you can either make factors of 24 and check to see if they add to be 10, or you can make things add to be 10 and check to see if they multiply to be 24. Who cares which one you do?
Does it matter if it's like which order they come in, a 4 or 6 or 6 or 5?
No, it doesn't, because it's sort of like if somebody said 7 times 3 and you said 3 times 7, you're both right. Multiplication doesn't care what order you multiply. They're all on the same level they're all at multiplication level. So it doesn't matter which order you do. So here, what goes in here then? What did we just figure out? Is 4 and 6 makes 24 and it makes 10 when you add them. So how do I finish this up? Sure, plus 6 plus 4. Or plus 4 plus 6. Those are the exact same answer.
No.
The order does matter though, the last number is negative.
No. As long as, no, stay with me. You ready?
But if you have...
No. You guys are saying, like, take the number and leave the minus sign. I'm saying if part of it's -7 and you take that -7, it doesn't matter which order you put it in.
No.
So let's do a problem with some negatives. What's up?
It does matter if it was -3 plus 7 or -7 plus 3.
No. Here's my point. Once you get the answer, does it matter which order you put the things in? No.
Oh, no.
You're talking about two different possible answers.
Okay.
I'm talking about... So you ready? Here we go. What about this here? So this is based on what we just did. So we should know what this is already.
X minus 12.
No. 12 and 2 don't make 2. Right? So you need factors of 24 that add to be -2. Yeah. 6 and 4, which one's negative? Why is the 6 negative? So that the answer comes out negative, right? Don't think of it as a lot of things to remember. The problem saying, hey, the bigger guy's got to be this. Oh, okay, thanks, problem. Of course the bigger one's got to be this, so that when you add them, it stays that. Right? All right, maybe. So now my point is, I like that you guys are saying you can't, 6 has got to be negative, but does it matter if you put the negative 6 there, or the negative 6 there?
Because
No,
the
that's my
multiplication,
point.
we can.
Exactly. So obviously if you made 6 go there, made it positive, that's not the right answer. But this you can write either way you want to. Maybe. All right, let's do one more with kind of a gross number. Yeah, let's see. Watch the way I put this together. Let's see. What the freak? Alright, so let me show you. I don't want to make a list of factors of 480. Because the number 480, how many ways can you break it up? Can you see? A lot. So you're like, oh, Jeff, what the hell? So this is why I show you a different way to look at it. I don't want to make that list of factors. Good God, man. And then I got to throw the test in with one problem. Done. Screw that. So what I start with, and can somebody tell me, are the numbers going to be the same sign or different signs?
Different.
Because they're going to multiply to be negative. Does everybody see that? All right, so here's my suggestion, and here's what a lot of teachers don't show for some reason. I don't have to make a list of factors. I can just start with things that add to be 74. But for example, not 70 and 4, right? Because one of them's got to be negative. So they actually have to kind of subtract to be 74, because one of them's going to be negative. So like 79 and 5. Does that make 74? Yeah, as long as the 5's negative. But what's 79 times negative 5?
We need to do it.
390?
Yeah.
Is that
Negative
what it needs?
395.
No. So it's too small, right?
Let's try negative, or 80. And
80 and negative 6 makes 74, right? And what's 80 times negative 6?
Negative 48.
Ding, 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 right?
Well, 18.
Do you guys see that? Do you have to do it that way ever in your whole life? No. You could make a list of factors in negative 48. Let's see, 10 and 48, 6 and 80, so, 240 and 2. And if you just happen to not think about these, holy shit, that's going to take forever. That's why I like this way a little bit better for the large, uglier numbers, because you have more control here. Here it's just like, oh, let's hope I get lucky. Here it's like, all right, that was too small, let me make it bigger. You can control it a little bit more, right?
But this one, it's not easy though. It's
No, okay. Yeah. So they're not all going to be easy. But the nice thing is, when this is 1x squared, I always know that this is what and what?
X.
X and X. And I just figured out the numbers that go here.
Yeah.
Yeah, 80 minus 6, or minus 6 and 80. I like it. If this would have been, can somebody tell me this answer real quick? If this would have been a minus here instead, what's the only thing that would have changed my answer?
The sign.
That would have been plus and that would have been minus, so that the big one's negative, right? All right, so, right now, immediately, I want you guys to do this. Oh, sure, of course. It's not a quiz or anything.